In this video, we're going to look at rules for exponents. We're going to look at the product rule for exponents, the quotient rule for exponents, which is also known as the division rule. We're going to look at the power to a power rule, the negative exponent rule, and the zero exponent rule. We're going to start with the product rule for exponents. The product rule for exponents says x to the n times x to the m equals x to the n plus m. In other words, if you have two powers with the same base multiplied together, you simply add the exponents. Here's some examples. Let's start with 10 to the third times 10 to the 2 power. We have the same base of 10 in each power. We can just add the 3 plus 2 and get 10 to the 5th. Now 10 to the 5th is 100,000. Now we have 10 squared times 10 to the third. That's 100 times 1,000. That would give you 100,000, right? So that rule makes sense here. The next example, we use x's instead of numbers. X to the 4th times x to the 5th. We have the same base in each power of x, and all we have to do here is add the exponents. X to the 4th times x to the 5th is x to the 4 plus 5, or x to the 9th power. Can we use this rule to simplify x to the 3rd times y to the 7th? The answer is no. And the reason it's no is we have two different bases. We have a base of x and we have a base of y. We can't use this rule when the bases are different. Let's look at the quotient rule for exponents. This rule says x to the n divided by x to the m is x to the n minus m. In other words, when you have two powers with the same base divided, you can just subtract the powers. Let's look at a simple example to start with. 10 to the third divided by 10 squared. That's going to be 10 to the 3 minus 2 power. We just subtracted the exponents. Well, 10 to the 3 minus 2 is just 10 to the first, which is just 10. What we've done here is we've divided 10 to the third, or 1,000, by 10 squared, 100. Well, 1,000 divided by 100 is 10, the answer that we got and the answer that we would expect. The next example uses x's. We have x to the 9th divided by x. Well, you first have to realize that x to the 9th divided by x is the same as x to the 9th divided by x to the 1st. We then can apply the division rule or quotient rule for exponents and subtract the exponents. X to the 9th divided by x to the 1st is x to the 9 minus 1, which is just x to the 8th. Here we're going to look at the power to a power rule and the extended power to a power rule. The power to the power rule says if we raise a power to another power, we multiply the exponents. So if we have x to the a power all raised to the m power, we then multiply the exponents a times m. The extended power to a power rule says if we have two powers inside parentheses multiplied together, x to the a times y to the b, and we're raising both of those to the m power, we get x to the a times m power times y to the b times m power. I know this is a little confusing, but maybe in the example below it'll make a little more sense. So let's look at some of these examples. 2 to the 3rd power raised to the 4th power. We take the exponents 3 and 4 and multiply them together. We get 2 to the 12th, which is what you'd expect because 2 to the 3rd is 3 2's multiplied together. And when you take that to the 4th power, you get a total of 12 factors of 2. Let's look at an example with x's. X to the 3rd times x to the, or raised to the 5th power. We apply the power to the power rule and we get x to the 3 times 5 power, or x to the 15. Now let's look at an example with that extended power to a power rule. Here we have x squared times y cubed inside parentheses raised to the 4th. We apply the power to the power rule to the x squared raised to the 4th to get x squared, or x to the 2 times 4. We apply the power to the power rule to the y cubed raised to the 4th, and that gives us y to the 3 times 4. So the result is x to the 8th times y to the 12th, and we can just write that as x to the 8th y to the 12th. Now we're going to take a look at the negative exponent rules. These rules say that x raised to the negative n power equals 1 over x to the positive n. And also, if we have 1 over x to the negative n, that's equal to x to the positive n. Now you notice wherever we have the negative exponent showing up, what we do is we invert the fraction or place it as a fraction and use the opposite power. X to the negative n we write as 1 over x to the positive n. When we have 1 over x to the negative n, we invert it and write it as x to the n, or x to the positive n. Here's a few examples. 2 to the negative third power we can write as 1 over 2 to the positive 3. We inverted the 2 to the third and used the opposite power. Now here's another example where we have 1 over x to the negative power of 9. We invert that x to the 9th and write it as x to the positive 9th. So opposite power and invert the fraction. Here's an example where we use this negative exponent rule in simplifying expressions. When we have x divided by x to the 9th, we can write that as x to the 1st divided by x to the 9th. And the division rule says we get x to the 1 minus 9. But that's a negative number. That's x to the negative 8th power. Well, we can write x to the negative 8th as 1 over x to the 8th power, 1 over x to the positive 8. We're going to take a look at the zero exponent rule. The zero exponent rule says x to the 0 power equals 1 for any and all x except x equals 0. In other words, anything to the 0 power equals 1. I'll say that again. Anything, positive, negative, whatever, raised to the 0 power equals 1. The only exception is 0 to the 0 power is not defined. Here's some examples. 4 to the 0 power equals 1. Negative 3 raised to the 0 power, that equals 1. And note the negative 3 is inside parentheses, so we're taking the 0 power of it. 2x raised to the 0 power is 1. Even 10 million, negative 10 million, raised to the 0 power, it's 1. Anything raised to the 0 power is 1. The exception is 0 to the 0. That's not defined. Now here's an example using the division rule for exponents that might show you why this rule is what it is. Let's say we have 2 cubed divided by 2 cubed. Now 2 cubed is 8. So really what we have here is 8 divided by 8. By the division rule for exponents, we get 2 to the 3 minus 3. Well, 3 minus 3 is 0, so that's equal to 2 to the 0. Well, by our exponent rule for zero exponents, that's 1. Well, isn't 1 what you would expect? Because 8 divided by 8 is 1.